Okay, good afternoon. So I hope that you have enjoyed your holidays. So let us go back to the lesson. If you remember the last session that we had before the break, I just gave you a problem and I asked you to solve that. So it might be that's a good problem to start with. This is a very nice problem to refresh your memory about whatever we had in this chapter. So I took notes from the previous video. So I gave you a triangle with these coordinates. So let us say the triangle was ABC, and then I have given you the coordinates of these three vertices. So these are the numbers. Minus 2 and 5, and C was 0 and minus 3. And using the tools in GeoGebra, I ask you for finding the area of this triangle. And then when I checked the video, I saw that we also used a tool in GeoGebra. Just by clicking on this triangle, we realized that the number for the area is 14 squared unit meter, square units. We want to find this today. There are two different ways, of course, for calculating the area. One is completely elementary. You really don't need to know anything about equations for the lines. I don't know the slope of the lines, but I will keep it later. For now, I want to use the ideas that we learned so far. For example, we learned that if two lines are parallel, this happens if and only if the k values are the same, or both of them are vertical. And we also learned that two lines are perpendicular. Do you remember? What was the rule? Two lines are perpendicular, either one of them is vertical, the other one is horizontal, or if neither of these things happens, the product of the k values should be equal to, do you remember? Minus 1. Yes? So if two, so we learned that if I have two lines, L1 is parallel to L2, if and only if k values are the same, whenever it makes sense, or one is horizontal and one is vertical. Yes? No, sorry. Or both are vertical. Yes? Because for the case that both of them are horizontal, I don't need to add it extra, because I know that if they are horizontal, k values are automatically the same. So I would say that two lines are parallel, either k values are the same, or both of them are vertical. In the case of vertical, I cannot say that they have the same k values, because the k values are not defined. And then do you remember I told you that L1 is perpendicular to L2 if and only if K1 multiplied by K2 is negative 1, or 1 is horizontal and 1 is vertical. Okay, so if you have forgotten these things, and we had also a very famous formula, 1-point formula for writing an equation for the line. Do you remember? Y minus y node is equal to k times x minus x node. If I want to find an equation for a line for which the k value is given and a point is also given, a point on the line is also given, I put them in this equation, and I immediately get an equation for the line. And I told you that what is the weakness of this formula? Do you remember? Yes?
It's not for vertical lines?
It's not for vertical. It cannot generate vertical lines. So if you are unlucky and your answer is a vertical line, you cannot expect to get that answer out from this equation. This is why we also learned about the general form of an equation for a line, yes. But mostly, this is enough for our purpose. Okay, I really want you to pay attention, even if you have forgotten things. I will try to refresh your memory by solving this problem. And then, after this problem is fully finished, in the way that I want to prove it, I will ask your opinion about, is there any shortcut to solve the same problem in a different way, geometrically, instead of analytic geometry, using analytic geometry. Okay, and I told you that in these cases, don't be very obsessed about doing a very precise picture for yourself, but of course, let us do something on the board here. So you really don't need to pay attention to real details. If you want, you can use GeoGebra to draw the precise form of this triangle, but we just need to convince ourselves about what is going on here. So let me just draw a set of coordinate systems, x and y, and then try to locate roughly these points here. The coordinates of A are 2 and 3, so it means that I have 2 units here. Yes. So I have 2 units, for example. And then what is the highest value that I need here? So 2 minus 2, 0. So 2 minus 2 is here. Yes. So for example, this minus 2. And then I have minus 3 up to 5 here. Hopefully it will work here. So let me make it bigger a little bit. Okay, so here, this is 1, 2, 3, 4, and 5. Okay, so this is the y-axis. And then I have 1, 2, and 3. Okay, good. So you really don't need to pay attention to the real details here. So here, A is 2 and 3. So this is my A. This is point A, 2 and 3. And point B is minus 2 and 5. So it's minus 2 and 5, 4 and 5. So this is my B. So this is 5 and minus 3. And finally, I have point 0 and minus 3, which is here. X is 0 and minus 3. Yes? So this is the triangle that I will have. So let me just draw it. Yes. The goal is to calculate the area of this triangle. Okay. So of course all of you know that the area of a triangle is the length of the base multiplied by the corresponding height divided by 2. But which one you want to take as the base, it's up to you. For example, I can choose this one to be my base. Then of course my height would be a line drawn perpendicular from here to this line. So it means, of course, I don't want to draw that picture unless you decide to do it with this one. If I want to take this one as the base, and then of course I need to continue this line, and then I need to draw this perpendicular line, and then this will play the role of my height, this will play the role of my base. I find these lengths and multiply them and divide them by 2. Of course, it doesn't matter. You can take this one as your base, and then draw a perpendicular line to this one. Then this will become your height, this will become your base, and then you do the same thing. If you do everything correctly, then what you get, it will be the same number. It doesn't matter. So, I don't know which one do you prefer. So which one do you prefer? Let us choose the one that the height is inside. Of course, this is not important at all. So let me take, for example, this one A, and then I draw this line perpendicular to AC. Okay, so for example, something like this. And then let me call it AH. Okay, now I want you to help me to solve the problem together. So if I want to find the area, so let us denote it by S for surface. This is very standard in geometry. The area of this triangle ABC in the picture that I have drawn here is 1/2 multiplied by the length of the base. In this case, I call it BC, multiplied by the height, in this case, AH. Okay? So I need to know these lengths, yes? Finding BC is very, very simple if you haven't forgotten things. So what is BC, do you remember? Or at least can you tell me what was the name of the formula that I want to use to find BC? Because for BC, I don't have any problems. You see, the coordinates of B and C are directly given to me, and I want to calculate the distance. Yes, Sergey?
The distance formula.
The distance formula. So do you remember what was the distance formula? So here, if I want to write the length of BC, I can write this square root. I can write the difference between the x coordinates. So let me write x sub b, meaning the x coordinate of the point B, minus x sub c squared, plus y sub b minus y sub c squared. And I told you it doesn't matter if you write it the other way around because of this power 2. Yes? I hope that you remember this. So calculating this is very, very simple. So this becomes square root of, you just read the numbers. What is x of b? The x coordinate of point B is minus 2, minus x coordinate of point C is 0, squared, plus the y coordinate of point B is 5. Please watch me if I am making a mistake. Please just tell me immediately. And then y of C is minus 3. And then a squared. Do you agree with me? Let us double check. X of B minus x of C and y of B minus y of C. That's correct. Let us calculate. Minus 2 minus 0 is minus 2 to the power of 2 is 4. 5 minus 3 is 8. 8 to power 2 is 64. So what I get is square root of 68 length unit. Of course that is okay, but I prefer to make it a little bit simpler. And you want exact values, so do not approximate these values. You always want exact values. So here, can you tell me how can I simplify a little bit? Simplify means that having a smaller number beneath the third sign. How should I do that? Yes?
Divide by 4.
By 4. So this becomes 4 times 17. But the square root of 4 is a complete square, so it becomes it becomes 2, and then square root of 17. Okay? So let us register this here. So it is 2 times the square root of 17 length units. Yes? That's actually the simplest possible case problem. That's an E-level question actually. But now we want to find the length of that orange height. Now I want to hear from you your strategy, and then of course I can fill up the gaps for you. But you tell me the strategy of finding the length of this orange line AH, and this more or less needs what we have done, what I have refreshed here, recap here, yes. Anyone else? Just think a little bit about that. First of all, tell me why I cannot use directly the distance formula. Because that is more or less the same strategy, yes? Here, I use the distance formula to find the distance between B and C. Why I cannot use directly the same formula for finding the distance between A and H? Yes?
Because we don't know the coordinates of H.
Because we still don't know H. So it means that if I know the coordinates of H, again I can use the distance formula because I have the coordinates of A. If I can find the coordinates of H, then I will use the same distance formula to find the distance between A and H. So now strategy becomes clear. My strategy becomes focusing my energy to find the coordinates of H. So you can momentarily forget about every detail in this problem momentarily. Just focus on finding a way to be able to find the coordinates of H. Exactly. So how should I do that? Just give me the strategies, the numbers, the calculations. We do it together here on the board. But just tell me, how should I find H? What is your strategy? What is your plan for doing that? Anyone else? Yes, I.
We use the other formula, the y minus y naught is equal to.
No, just give me the strategies. Yes, I can do the details. So what is your goal? Your goal is to find what?
X and y of A
Okay, how?
using the other formula.
Okay, so you didn't get my point. Okay, continue. Because I don't want you to tell me which formula to do what. That I will fill it up later. But what is your plan for doing that? So you want to find the coordinates of H. But what is your first step?
To put the values of A into the formula.
Which formula?
Y minus y naught is equal to k times x minus x naught.
So this gives me what? If I use that formula, it gives me the k value of what? Because if you want to find the k value. Can I calculate the k value of this directly by that formula that you are mentioning? Because that formula that you are mentioning for k value, you remember delta y divided by delta x, meaning that y2 or y1 minus y2, it doesn't matter. So for this formula being useful, how many points I need on my line? I need two points. Yes? So from this orange line, how many points do I know? One. Yes? So still one is missing. So is that what you mean? Okay, so this doesn't directly work. The problem is the same. You see, if I want to use this for finding the k value, it means that I have to have 2 points known for me on this line. But I don't know, I have only point 6. So this direct method does not work. Yes?
We need to use the perpendicular formula.
How?
So we need to know the k value of BC.
Is it possible to know the value of the k value of BC?
Yes, because we have 2 points.
Yes, exactly. The formula that Haya mentioned is useful for calculating the k value of BC. Because I know B, I know C. So let us use that, exactly. So let us do it one by one. So I would write the k value of BC is equal to the y value of B, for example, minus y value of C, divided by the x value of B minus x value of C. Yes? So let us continue. So what is the y value of B? You go there and read it from there. It's 5. Minus what is y of C is minus 3. And then divided by x of B is minus 2, minus x of C is 0. And if I calculate this, the numerator becomes 8, the denominator becomes minus 2. So this becomes minus 4. But this is the k value of BC is minus 4. Now, can you tell me here, because I know that AH is perpendicular to BC, can you tell me what is the k value of AH then? 1 over 4, yes? Because the product are supposed to be minus 1, yes? So let me ask you, are you comfortable with the number that I have written here or no? This value should be something that when multiplied by minus 4 gives me negative 1. So if I ask you what is the number that is multiplied by minus 4 and the result is minus 1, I don't think you have a hard time to understand that is 1 over 4. Yes? You remember what was the rule? Reciprocal multiplied by a negative sign. If I ask you what is the reciprocal of minus 4, it is 1 over minus 4. and then you multiply it by a negative sign, it becomes 1 over 4. Yes? Yes or no?
Yes.
Okay. So now I have the K value for AH. So Haya, do you understand now? So this is an indirect way. So your method was correct. We wanted to find the K value, but this formula for K value doesn't work in this case. So we find the K value of BC and use the perpendicularity to find the K value of AH. But then what is the purpose of finding the K value of AH in the first place? Yes?
Now we can put the coordinates of A and the K value of AH
Yes?
in that formula to find the coordinates of A.
No, not yet. How? I don't understand how. Because if I ask you, do you know a point on the orange line, you would say yes. Which point do I know? Point A. Do I know the K value of the orange line? Yes. What is the value? Is this number. Okay, then what? Still, it is not easy to jump to conclude something about the coordinates. What should I do? Give me the strategy. Okay, let me ask you one question. Can I find an equation for the orange line? Yes or no? Can I find an equation for the orange line using which formula? 1 point formula. Yes? So if I ask you what is an equation for AH, you would write y minus y node is equal to the K value of the line times x minus x node. Okay, help me to write it. What should I write for K? I am concentrating on writing an equation for this orange line. So what should I should write 1 over 4. And then I have x, and then here I have y, minus minus. So what should I write for y node?
Coordinates of A.
A coordinate of a point that I know. I only know point A.
Yes.
So it is 3, yes? I put 3 here, and what should I put here? 2. So this is an equation for AH. And let me simplify that. So it becomes 1 over 4x. 1 over 4 times minus 2 is minus 1 over 2. And then I move 3 to the right. It becomes positive. So then it becomes y equals to 1 over 4x. What is the answer to this in your head immediately?
5 over 2.
5 over 2. So that is an equation for AH. I hope that you haven't missed what was the goal. What was the goal? I did all these things because I want to find the coordinates of H. Because if I know the coordinates of H, I can use the distance formula to find the distance between A and H, and I am done. So, but instead, so far I have found an equation for that line. So you see that that is a line goes to infinity. I found an equation for it. But how can I find the coordinates of H now? There was also another part of the lesson. We did it all of these, more or less these things in the last session. Yes?
That point should be, the coordinate should be the same, or should work on the equation of BC and AH.
Yes, so it means that I set up a system of equations. One equation is equation of BC. One equation is equation of AH. So then it means that I am still in trouble because I don't know the equation of BC. So I find an equation for BC. I already know an equation for AH. I intersect them. The intersection point is exactly point H, and then I will be done, hopefully. That's a hard problem, but if you break it into parts, every part is understandable. So you should be able to combine them. So let me just do this here. So my goal is to find the coordinates of H, but I realize that it is better to find an equation for BC. I already know the length of BC. That is necessary, but not enough. I also need to know an equation for BC. Okay, how can I do that? I need to find a k value for BC, but I already have it. It is -4. And then I use 1-point formula this time for BC. Okay, now help me to write the numbers in. So it becomes y minus, instead of k, what do I need to write? -4. For x node and y node, in this case, you have two options available. Yes? Either you choose the coordinates for B and put them here, or if you want to, you can choose the coordinates of C and put them here. For me, because C contains a 0, I prefer to use 0, the C. So it means that instead of y node, I put -3, and instead of this one, I put 0. So here I used C. You could use B, it doesn't matter. Let us simplify this. This becomes y plus 3 is -4x. I move this to the other side. So an equation for BC is -4x minus 3. So if I ask you what is the difference here and there, I hope that you realize that. Don't get confused. This BC equals to this number. Here by BC I mean the length. Here by BC semicolon I mean an equation for this line. Yes? And now I want to find the coordinates of point H. You see H lies on this line on the one hand, lies on this line on the other hand. So if I ask you what H is the intersection point between these two lines. Yes? And whenever you want to find an intersection, I told you what to do. Set up a system so that one equation of this system is equation of AH here. Y equals to 1/4x plus 5/2. Another equation is y equals to -4x minus 3. Yes? And try to find x and y so that both of them are simultaneously satisfied. But I also told you how to solve these things. This is very simple. Because this is y, this is also y. So it means that these two values should be the same. Yes? So this means that I have -4x minus 3 equals to 1/4x plus 5/2. And if I want to solve that, this is a Math 1C problem with denominators. I want to get rid of denominators. I multiply everything by 4 to simplify that. So it becomes -16x minus 12 is x plus 10. And then I move this to the left, it becomes -17x. I move this to the right, it becomes how much? 22. That's very strange that this number is so bad, because apparently, let us see what happens. So then x becomes what? X becomes -22/17. Exactly. You have to keep the exact value. Okay, can you tell me what is the meaning of this number that I got here? What is this number?
Coordinates of H.
X coordinate. X coordinate of H. Now I plug this back into this equation or that equation, it doesn't matter which one, you get the y coordinate. For me it is better to plug it here, less fractions involved, yes? So then I put this here, y becomes -4 times x. So if you do it in your head, 4 times that is positive, 88/17 minus 3. Okay, do it in your head, what's the answer? 88/17 minus 3?
It's like 1.
So what is the denominator?
17.
Denominator is 17. So you need to multiply 3 by 17. How much?
37/17.
Yes, 37/17. 3 times 17 is 51. 88 minus 51 is 37. Okay, the numbers are a little bit strange for me here. but this is what it is. Let us work with it. Have you detected any kind of because when I check by GeoGebra, the area is a nice number. The area is 14. And then I have a lot of fractions and square roots involved. So, if I want, so therefore, the number that I was, the point that I was looking for is h, is with the coordinates minus 22 over 17, and then 37 over 17. Yeah, a strange number, but anyway, that's h. Yes?
Yes.
Now, I hope that you haven't missed the goal. What is the goal? What was the goal from the beginning? I have this h. And now what was my goal? My goal was to use the distance formula to calculate the length of AH. Yes? So what I have to do, I have to write the length of AH is equal to square root of the difference between x coordinates squared plus the difference between y coordinates squared. Yes? And now let us continue. So what is the x coordinate of A? It was given to me in the beginning. It's 2. So it is 2 minus this number, which becomes what? Plus 22 over 17 to the power of 2. And then what do I have here? Y of A. Y of A is given from the beginning 3 minus 37 over 17 to the power of 2. Okay, let us do the calculation in our head. So, okay, tell me, what is this one? It shouldn't be hard. Multiply 17 by 2, 34. 34 added here. 56. 56 to the power of 2, 17 to power of 2. Yes? And then what is this one? Multiply this by that, it is 51. Subtract it, it is 14 to power 2, 17 to power 2. I hope that I haven't done any mistakes. Did you check any mistakes in my calculation? Did you see any? Okay. So this one, the denominators are the same, so I would write it like this: 56 to power 2 plus 14 to power 2, 17 to power 2. But then a square root of this one, the denominator becomes 17. Do you agree? Because the square root of this plus the square root, this I have to calculate, I don't know. This I have it in my memory, 196. But 56 to power 2, what happens for 56 to power 2? So you need to multiply, yes? So 36, 33, 30, 28, yes? 6, 3, 1, 3. Am I right? Can you please check that calculation for me? 56 times 56?
It seems to be correct.
Okay. So it is 3136 square root. Yes? Did you calculate it or not? 56 times 56. 56 times 56. No, I don't know why this doesn't work. Yes. And is there any square root for that?
Yes.
What is that?
Oh, wait.
No, sorry, so I made a mistake here. I have to add 196 to it as well. So this is plus 196. Okay, what is that? 3136 plus 196. 33. But this is very strange because this is not going to work. 3332. Yes? So this is AH. And I don't think we have a complete square root there. No. So let us keep it like that. But then S is this number. This number times that number times that number. But I have this number here, this number there, and I have 1/2. So I don't know, might be I have done some mistake somewhere. So S or the GeoGebra is not sensitive to decimal points when I was calculating it. So what happens? I will check it again. So this becomes 1/2 multiplied by BC is 2 square root of 17. And then times the square root of 3332 over 17. So this is the area units. But these two and that two are simplified. So this means that the area, if I haven't done something wrong, this and that one are cancelled. This becomes, by the way, square root of 17 divided by, I hope that you agree with me that I can write it like this. Do you agree with me or not? Because 17 is the square root of 17 times another square root of 17. One of the square root of 17s will cancel this one. One of them will be left, so I can write it in that way. Yes? But I don't think there is a hope that we can get 190. Who knows? Let us check our chances.
No, it's right. It's great.
Is it right?
Yes.
Okay, good. So it is 14. Now the reason that I realized that it's going to work, because I immediately realized that I can simplify it in that way, and then this one divided by that one is 196. And 196 a square root is 14. Let us double check. Let us double check. Let me double check. 3, 3, 3, 2 divided by 17. Yes, that's correct. 100% correct. So we didn't do anything wrong. Everything was okay. But please, for the time being, I really want you to know what I am doing with numbers. But if you don't like to work with numbers, you can just stop here, put this in your calculator and get that number. Okay? I myself prefer to do the calculations as much as I can using my brain. And when I stop, then I use the calculator. But if that is not good for you, you can just put this number directly in your calculator in exact mode, and then you will get this number immediately. Sorry, you get this number with an approximation. That's the bad point about calculators, unless you have an advanced calculator or you put it in GeoGebra or a symbolic calculator. But anyway, this is an extremely important problem. The reason is that we reviewed a lot of things, more or less everything that you needed in this chapter. So we used the distance formula. We used the setup. First of all, we learned how to set up the coordinate system, which was an elementary problem, and then we used the distance formula, and then we used the 1 point formula 2 times, and we used the k value, and then we used perpendicularity. The only thing that we haven't used in this problem was the lines being parallel. But other than that, we have done everything right, and the answer is 14. Okay? Is that clear? So, the area of that triangle is exactly 14 area units. I really wanted to do this in this way. The reason is that there is a simpler way to do it, if you just care about the area. But in the exam, I might ask you to find an equation for the height. Then, of course, you need to do some part of this problem. But now let me ask you, can you tell me how, if you don't know anything about these analytic geometry, you just know elementary, I don't know, Grundschule geometry. Can you calculate the area again without using any one of these methods? Okay, so let me bring this picture down. Here, let me clean these things not to distract you. So here, let me clean these. Yeah, so here, that 5 is good to have it somewhere. Do you have another strategy to tell me how to calculate the area of this triangle? Or you don't need to be 100% correct or sure. You can just talk about your idea. Yes, Rasmus, do you want to say something?
Might have something. It doesn't feel very elegant, but
Yes.
we could calculate the bounding box of this triangle, like the
Yeah, exactly. That's the idea that I have. Yes.
where the corners of
So why don't you call it an elegant way?
because then we would have to calculate the area of the parts of this bounding box.
Yes, yes.
Isn't part of our triangle.
Okay, but that is doable using
That's-
elementary
That's
mathematics.
doable because all the sides of those triangles are completely vertical or
Yeah, or horizontal.
horizontal.
So the reason, by the way, I can give you the same type of problem in the exam, but I can design these numbers in a way that one of these are either horizontal or vertical. In that case, you really can read the height by the coordinates. The reason that it becomes hard, because I wanted to calculate this height, and that is neither a vertical line nor a horizontal line. So I need to know the coordinates. So here, what Rasmus is mentioning, and that's a very nice method, I would say that I will draw a line here, parallel to the x-axis, parallel to the x-axis, parallel to the y-axis, and parallel to the y-axis. Yes? If you are smart, and then you can find this, it might be easier for you, because you are interested in finding the area of this triangle. You can immediately calculate the area of this rectangle and subtract these three triangles out of it. Yes? And that is, you really don't need to do messy calculations. Might be it is a little bit boring, but I mean it is very quick. Let us do that. First of all, tell me what is the area by reading the coordinates. What is the area of the rectangle? You need to find this height and you need to multiply it by the width. Yes? So what is the height? You remember this number was 5. This number is -3. So what is the height? 8. So 8 multiplied by. Can you read me the width here?
5.
From -2 to, was it right?
-3.
-3 to 2 is 5. So this is 40. Yes? So the area of the rectangle is 40. But can you tell me what is the area of this right angle triangle? This would be this multiplied by this divided by 2. Do you understand or not? That is the area of a right angle triangle. I have to multiply these two edges, the length of these two edges, and divide by 2. The length of this edge is already known. What is that? 5. Multiplied by the length here. Can you read it from the coordinates? 3 to 5, 2. And then divided by 2, which is 5. Yes or no? Let us go to the next one. This narrow one here. What is the number from here to here? It is 6. Multiplied by this width, which is 2. Yes? And then divided by 2, which is 6. Yes? And then let us do the same thing here. What is this height? 8. Multiplied by, what is the width? It is 3. Divided by 2. It is how much? 12. And let us add these three numbers. It is what? 23. So we made a mistake. Is that right? 5, 6? Yes?
In the first one, it's...
In here?
yes, it's 4 times 2.
4 times 2, why?
Because
So,
it's B is negative 2 pi.
so let me see, which one was the first one? Well, this one was the first one, yes?
Yes.
So the width is how much?
It's 4 between B and the corner.
Uh,
Because B is negative 2. No?
Yeah, it's
Negative.
oh yeah, it is 4, sorry. So what is the answer? Is 4. And then it is even worse now. Yes, so I made them solve because the reason is that I made a mistake because I already considered all of these minus 3. So I don't know where that minus 3 is coming from here. It's minus 2. I don't know why I have written minus 3 and you didn't complain. So I think we have, so this one will affect this one. So now it is corrected. This one will also affect which one? This, the last one, yes?
Yes.
This is 2. So this is what? 8. And this one, what about this one? That is 2. And that is how much? 6. So it is 6. No, I don't know, it doesn't work.
It's even worse now. We're just getting lower and lower.
No, might be, so let us just do the calculation. It cannot be not right. So let me just make sure everything is right. So B is what?
No,
B is
Baba.
minus 2. So here is minus 2 definitely. A is 2, so here is 2, that's correct. And C is 0, so now the height, 3. So A is 3, yes, that's correct. And then B is 5,
Baba,
yes?
the area of the rectangle is 8 times 4, not 8 times 5. So it was 32.
Oh yeah.
Okay, so let us just calculate again. The area of the rectangle was how much you say?
8 times 4.
8 times 4 minus 8 times 4. Yes, you are right. From here to here is 8, from there to there is 4. Yes, you are right. And then the area of that rectangle, triangle is how much? Is 4 times 2 divided by 2 plus this one was this number. And now here, what is the height? Is 6 times the width is 2 divided by 2 plus, and this one finally is how much? 8 times 2 divided by 2. Hopefully this is correct, yes? This becomes 32 minus 4 plus 6 plus 8. So this becomes 32 minus 18, and then this becomes 14. So you see, this is completely elementary without having any kind of these messy calculations. But the reason that I didn't suppress this, I want you to know this method, is because it is refreshing a lot of things. It's more or less everything that we have learned in this geometry in one problem. Yes? Any questions here? No? Okay, so this lesson is actually completely finished. Let me stop recording now.